Hey guys, today we're going to talk about lesson 12.1.1, which is going to be writing the equation of a circle. So let's first remember what is a circle. And a circle has a center, and every single point around the circle on the circle is exactly the same distance away from the center. And of course we know we call that the radius. Okay, so we're going to talk about the radius today, we're going to talk about the center today, and I'm going to call this point HK. In algebra, we use HK to represent a locator point. In the case of a circle, the locator point is just the center of the circle. That's going to become important later on. What if I wanted to graph a circle? Okay, so these are my axes. If I wanted you to graph the same circle I have, I would want to tell you the ordered pair for the center, and I would want to tell you the length of the radius. And if I was on graph paper, I'd probably count straight, right, left, up, or down. I probably wouldn't want to go diagonal, but this diagonal is really going to help me when it comes to the equation of the circle. So if I select an easy example, my x and y axis are giving me that the center of the circle for now is 0, 0. So I'm going to ignore this for now. Okay, the radius is some r. Now again, if this is on graph paper, this point right here on the circle, just like every other point around the circle, would represent some ordered pair. And of course, ordered pairs are x comma y. Now, the most important thing we've probably taught you all year this year, the thing we've done the most on, hopefully you guys realize we can use here. So from 0, 0, if I move to the right, I'm moving to the right x units, okay? And I'm moving up y units. And because it's on graph paper, we know that that's a right angle. So hopefully you guys are seeing, oh, x squared plus y squared would have to equal the distance squared, or r squared. So this is actually the very basic formula for the equation of a circle. Now, it gets a little bit more complicated when we move the center away from 0, 0, or away from the origin. And there's lots of math that goes behind it. It goes back to Pythagorean theorem. For today, I'm just going to tell you that the equation of a circle is x minus h squared plus y minus k squared is equal to r squared. Okay, so you're going to want to write this down. You're going to want to use these notes when you get to your assessments. Okay, and again, HK represents the center of the circle, and of course R represents the radius of the circle. Now, let's look at some examples of what you might have to do today. I also want to make sure that I'm drawing your attention to the fact that this says x minus h and y minus k, or the opposite of h and k. And that's going to be really important when we go to write equations here. So example 1 says write the equation of a circle given the center and the radius. So they're telling me that 3, negative 6, okay, 3, negative 6 is the center of my circle, and that the radius is 7. So all I need to do is use my equation, x, the opposite of h. So this represents h and k, and obviously radius is 7. So x minus 3, because that's part of the equation. You're going to learn next year in Algebra 2 a little bit more of the why behind why do we change the sign. But when you go from a graph to a number trapped in parentheses with a variable, you're going to switch the sign. So x minus 3 squared, always squared, and we're always adding, plus y, now minus a negative 6, of course, is really just to be adding, equals r squared, 7 squared. Now, as teachers, we don't want you to write 7 squared. You can do 7 squared either in your head or on a calculator. We want you to write 49. And that's really all there is to it. So let's take a look at part B. Same concept. Remember, this represents h and k. So all you have to do is remember to switch the signs. Remember to square it. Remember to add. Now here, with y, I'm subtracting 0, and you could certainly write y minus 0. R squared, 4 squared is 16, okay? You could write y minus 0. It's also completely acceptable, and probably written a little bit more like this, without writing any 0 there, okay? Either of these two is absolutely fine, okay? Then, sometimes what's going to happen, instead of us giving you the center and the radius, we're going to give you the equation and we're going to ask for the center and the radius. So remember, we're just going to look right here. What's being subtracted from the x before it's squared? Well, nothing is. That means the h value is 0. What's being subtracted from the y before it's being squared? Nothing. So the y value, or the k value, is 0. Now, here's a thing where a lot of students just mix this up because they're going too fast. Remember that this thing at the end represents r squared. So I want to write 9 equals r squared, and I want to find the square root of both sides. Of course, we can do that really quickly. The square root of 9 is 3. Now, technically speaking, when we solve this equation, we should get r equals plus or minus 3, but because we're talking about a distance, we always take the positive value. It doesn't make sense to say, oh, Mrs. Miller, how far do you live from Solon High School? Oh, I live about negative 12 miles from the school. That doesn't make sense. It makes sense for me to say 12 miles and then give a direction. Okay? Part B, same thing. Well, what is... I'm with Mr. Carnes. I like writing formulas a lot. Okay? It just kind of helps me see what's going on. So if I'm looking for the center of the circle, HK, remember, this says minus 6, this says minus h, so h is just 6. This says minus k and positive 20, so k must be negative 20. Okay, so we're switching both signs. Anything trapped inside the parentheses with a variable, you're switching the signs to find the locator point. Now, 19 is equal to r squared. How do I find what radius is? Well, of course, I just use my calculator. I find the square root of 19. And I could write that it's exactly the square root of 19. That would be most exact. Or I could say, well, it's approximately 4.4. Okay. Last example for today. Well, what if I'm actually supposed to graph a circle? And I would say if you're asked to graph a circle, it helps to first find the center. That's what we just practiced. Okay. Opposite of plus 4 is negative 4. Opposite of minus 2 is positive 2. And of course, 25 equals r squared, so the radius is 5. So if I'm going to graph this, and graphing paper would be best. I don't have graphing paper right now. So I'm just going to go 1, 2, 3, 4, 1, 2. There's my center. Okay. Then my radius is 5, so I'm going to count to the right 5 and make a little arc. I'm going to count to the left 5. 1, 2, 3, 4, 5. I'm going to go back to the center. I'm going to count down 5. 1, 2, 3, 4, 5. And I'm going to count up 5. 1, 2, 3, 4, 5. Now, I don't have graph paper. I did this counting very, very loosely. You're going to do what you can to try and make your circle look like a circle. When you're first starting, these are going to look more like rhombi or squares or footballs than circles. Do your best. If your teacher can see where your center is and can see what your radius should be, you're going to be just fine in graphing a circle.